In thermodynamics, the triple point of a substance is the temperature and pressure at which the three phases of that substance coexist in thermodynamic equilibrium. For example, the triple point of mercury occurs at a temperature of 38.8344 AA degrees Celsius and a pressure of 0.2 megapascals. In addition to the triple point between solid, liquid, and gas, there can be triple points involving more than one solid phase, for substances with multiple polymorphs. Helium-4 is a special case that presents a triple point involving two different fluid phases. The triple point of water is used to define the Kelvin, the SI base unit of thermodynamic temperature. The number given for the temperature of the triple point of water is an exact definition rather than a measured quantity. The triple points of several substances are used to define points in the ITS 90 International Temperature Scale, ranging from the triple point of hydrogen to the triple point of water. Triple points of water, gas liquid solid triple point. The single combination of pressure and temperature at which liquid water, solid ice, and water vapor can coexist in a stable equilibrium occurs at exactly 273.16 K and a partial vapor pressure of 611.73 pascals. At that point, it is possible to change all of the substance to ice, water, or steam by making arbitrarily small changes in pressure and temperature. Even if the total pressure of a system is well above triple point of water, provided the partial pressure of the water vapor is 611.73 pascals, then the system can still be brought to the triple point of water. Strictly speaking, the surfaces separating the different phases should also be perfectly flat, to negate the effects of surface tensions. The gas liquid solid triple point of water corresponds to the minimum pressure at which liquid water can exist. At pressures below the triple point, solid ice when heated at constant pressure is converted directly into water vapor in a process known as sublimation. Above the triple point, solid ice when heated at constant pressure first melts to form liquid water, and then evaporates or boils to form vapor at a higher temperature. For most substances the gas liquid solid triple point is also the minimum temperature at which the liquid can exist. For water, however, this is not true because the melting point of ordinary ice decreases as a function of pressure, as shown by the dotted green line in the phase diagram. At temperatures just below the triple point, compression at constant temperature transforms water vapor first to solid and then to liquid. The triple point pressure of water was used during the Mariner 9 mission to Mars as a reference point to define sea level. More recent missions use laser altimetry and gravity measurements instead of pressure to define elevation on Mars. Other triple points of water at high pressure. At high pressures water has a complex phase diagram with 15 known phases of ice and a number of triple points including 10 whose coordinates are shown in the diagram. For example, the triple point at 251 K and 210 Pa corresponds to the conditions for the coexistence of ice-3 and liquid water, all at equilibrium. There are also triple points for the coexistence of three solid phases, for example ice-2, ice-V and ice-6 at 218 K and 620 Pa. For those high-pressure forms of ice which can exist in equilibrium with liquid, the diagram shows that melting points increase with pressure. At temperatures above 273 kelvins, increasing the pressure on water vapor results first in liquid water and then a high-pressure form of ice. In the range 251–273 K, ice I is formed first, followed by liquid water and then ice-3 or ice-V, followed by other still denser high-pressure forms. Triple point cells are used in the calibration of thermometers. For exacting work, triple point cells are typically filled with a highly pure chemical substance such as hydrogen, argon, mercury, or water. The purity of these substances can be such that only 1 part in a million is a contaminant, called 6 nines, because it is 99.9999% pure. When it is a water-based cell, a special isotopic composition called VSMOW is used because it is very pure and produces temperatures that are more comparable from lab to lab. Triple point cells are so effective at achieving highly precise, reproducible temperatures. An international calibration standard for thermometers called ITSA Euro 90 relies upon triple point cells of hydrogen, neon, oxygen, argon, mercury, and water for delineating 6 of its defined temperature points. Table of triple points. This table lists the gas liquid solid triple points of several substances. Unless otherwise noted, the data comes from the U.S. National Bureau of Standards. Note: for comparison, typical atmospheric pressure is 101.325 kilopascals. See also, critical point, Gibbs phase rule, references.